Hi everyone, welcome back to Noah's Chem Corner. You are going to the place learning chemistry the easy way. Today, we are continuing our basic chemistry series where we simplify concept and build your foundation step by step. If you're new here, don't worry, the full playlist for this basic chemistry series I'm pinning here. So, don't want to waste the time, let's get started. So in today's episode, we are going to study with the shapes of molecule. Okay, how to assign the shape of molecule. Usually, we are assigning the shape of molecular compounds through VSEPR method. Okay, valence shell electron pair repulsion theory. Okay, so it's very simple. So the rule is first shape of the molecule is depend upon the electron cloud on central atom. See, only on the central atom. How many electron clouds are there on the central atom? If two electron clouds are there, they tend to occupy maximum distance far away because the electron repulsion will be there. For example, central element is there and two electron cloud. So electron cloud means two kind of clouds are there, like bonding pairs are there as well as lone pairs are there. Okay, so for an element, two electron cloud means they will tend to occupy maximum distance far away. Why? Because all are electron. Bond means nothing but electrons. So two electrons are there. So here also two electrons are there in one bond. So these electron cloud are repel each other. So they will tend to occupy maximum distance. So this repulsion is actually make the shape of molecule. So you have to say if two is the thing, like two electron clouds are there, they will align like a linear shape. Okay, and the bond angle between them is 180. If three things are there, the maximum distance will be trigonal planar, isn't it? Because if you know, if three lines are there, how do you align that one? Like in order to minimize the maximum repulsion, right? In order to minimize the repulsion, we need to locate them like a trigonal planar shape. Then only it will be correct. Okay, so that's why what you need to do is just study like two linear. 3 means maximum distance will be trigonal planar, and see 4 means tetrahedral. See the bond angle 109.5 here, and trigonal planar was 120. And 5 means trigonal bipyramidal. Two bond angles will be there, 90 and 120, and 6 is octahedral with a bond angle 90. That's all. Okay, 2 linear, 3 trigonal planar, 4 tetrahedral, 5 trigonal bipyramidal, 6 octahedral. That's all. Now let's see. And also one more thing, single bond, a double bond, triple bond. You can consider like a single entity, like single electron cloud. Let's see how these things are working. Okay, for example, CO2. So first of all, you need to draw the Lewis diagram. So CO2 means carbon is 4 electron in number, like 4 valence electron is there. Oxygen is 6 valence electron is there. So 2, 4, 6 will be here, and here also 2, 4, 6 will be there. And how do you draw the Lewis structure? We already discussed that one. You can check the video. And so see, so this is the Lewis diagram we can get for the CO2. So here you tell me what's for central atom. See, we are only looking with the central atom. Central atom, how many electron clouds are there surrounding central atom? You can see there is one electron cloud in the left, like one electron cloud, and this is second electron cloud. Because I told you single bond, double bond, or triple bond. Consider like single entity. So here even it's double bond, you do not want to consider like two electron clouds are there. No. Okay, there is only one electron cloud here and the another electron cloud is here. So two maximum distance means you have to say it should be aligned in a 180-degree bond angle, or the shape is what you call linear. Okay, so here you can see two columns like electron geometry as well as molecular geometry. Okay, so what do you mean by electron geometry? Electron geometry means how electrons are arranged themselves, and molecular geometry means what is the shape. So if there is no lone pair, see very careful, if there is no lone pair on the central atom, then the electron geometry and molecular geometry will be same. So here electron geometry is linear. Similarly, you can say molecular geometry is also same. No difference, correct? So in this way, you can say CO2 is linear. If you want to see the shape of the CO2, so now see the thing. This is what you mean by CO2. Like see the linear shape, even it's a double bond, it's it's bonded to the same atom. So the same linear shape will be there. Okay, so see here you can see electron geometry, it's linear, and see molecular geometry is also linear. Okay, that's the thing. Now let's see the next one. For example, the next one is BCl3. So BCl3, boron is 3 electron, like 3 valence electron is there. Chlorine is 7 valence electron is there. So the structure will be like this. So chlorine, I'm not minding about this chlorine lone pair. So after all, what's the thing? Central atom. See now 3, even it's single bond, no issue. 3 electron clouds are there. So now you know what's the shape? Yes, it should be trigonal planar. So see the bond angle, this one will be 120. And as you know, the same geometry, like molecular geometry is also the same. Okay, let's do in this picture. BCl3. Okay, it's just BF3, same like BCl3. So see, electron geometry is trigonal planar, molecular geometry is trigonal planar, and this is what you mean by trigonal planar. Okay, so this is the shape. It's in the planar molecule, just one plane. You can see this trigonal planar. Okay, now let's see the next one, and CH4. So CH4 means carbon, a 4 electron is there, and see 4 hydrogen atom is there. So now the electron cloud is 4. So 4, what's the maximum distance? Yes, it's tetrahedral. So the molecule have to arrange like a tetrahedral. So this is what you mean by tetrahedral. Maybe you are not that much of familiar with the tetrahedral. Like you can imagine like a pyramid, and top of that one more element is there. Okay, like one more atom is there. So let's see, this is what you called pyramid. So see, the base is like a pyramid, and the top there is one more extra thing. So see, without the top you can consider like a pyramid. Got it? Or you can imagine like inside the middle part, the center is actually inside the pyramid, the carbon atom is there, and all hydrogen atom is pointed towards the corners of the pyramid. In that way also you can imagine. So anyway, this is what we call tetrahedral. And see, all angle, like all the angle is 109.5. Okay, here also you can see electron geometry as well as molecular geometries are same, because there is no lone pair of electron on central atom. So that's it. Then PFI. What about the PFI? So maybe you already imagined PFI means phosphorus is 5 electrons, 5 valence electron is there. So 5 phosphorus is there. Sorry, 5 fluorine is there. So 5, the whole shape is trigonal bipyramidal, which means a triangle base will be there, and the center you can see phosphorus, and top and bottom there is one more, like 2 more fluorine atoms. Okay, so this shape is what you called trigonal bipyramidal. So here you can see 2 bond angles are there, like this is one bond angle which is 90, and see in between the planar fluorine atom, there will be 120 difference. Okay, let's see in that diagram. So see, it's again the trigonal, like in this way you can think about it. So see, there is a trigonal planar is there, and top of the thing, top and bottom, there is an extra fluorine, like one more atoms are there. So that's why we are called trigonal bipyramidal. Okay. Right. And the last one, you can consider SF6. So SF6 means, so sulfur is 6 valence electron. So see here, sulfur with the 6 valence electron. So all the valence electron is satisfied by fluorine. So sulfur is a central, and 6 bonds are there. So see, this is what you called octahedral. So otherwise you can call the square bipyramidal. So see, the base is like a square. The square planar is there, and top and bottom there is extra atoms. That shape is what you mean by octahedral. Okay. So here, what about the bond angle? See here, this bond angle, like can you able to see this bond angle is 90, and also see, I will show this bond angle. See the thing, this is what I called square bipyramidal. So see, since it's a square, this angle is also 90. Similarly, this angle is also 90. So there is not two bond angles, it's all are one bond angle which is 90. Okay, so those are the basic shapes of the molecules. Okay, now let's see what about this SO2. How do you do with this SO2? Okay, okay, sulfur 6 valence electron is there. So 2, 4 and 6. Oxygen is also same family. It's 6 electrons are there. So you know that this is the shape of like the Lewis structure. So how do you draw the Lewis structure? Again, I'm telling the video we already done, so you can look at that one. Okay, so see here, what's the problem? Is there any difference? Here you can see this is one electron cloud, double bond or single bond, not an issue, but bonding electron. Here also bonding electron is there, so second electron cloud. But here you can see some electrons are there which is not take part in chemical reaction. Okay, so the valence electron but not take part in chemical reaction, which is called a lone pair. Okay, so here how many electron clouds are there? It's not about bond pair, one extra lone pair is also there. So you can say you like AB2E type. In that way also you can represent. AB2E type means what I meant, a central atom is at the bottom, center, like center atom is there and two bond pairs are there and one extra electron is there. This is what you mean by AB2E. So all the top thing you can write like, see, CO2 is AB2, this is AB3 and this is AB4. Like that you can tell AB5, AB6. Okay. So now what we are discussing, AB2E. Okay. So in this case I am just changing this A with the sulfur and the bond pairs are there. Okay. Okay. Now you tell me, so this is 3 electron cloud. So 3 electron cloud maximum distance means you know that that is trigonal planar. Okay, what we studied, it's trigonal planar because 3 maximum distance they will align like a trigonal planar. But the problem is one is not an atom. So you can't say the shape is not like a trigonal planar. When you want to say about the shape, you can ignore the position of this lone pair. Okay. When I'm saying ignore, it's not like, okay, trigonal planar -1. Okay. Like linear. No, it's not about linear because the effect is there. Sulfur, 2 bond. But the problem is what? Here its electrons are there. Due to this repulsion, so this will repel again. Even though there is no atom, the still repulsion is there. So that it's not aligned like a linear shape. So what you are expecting like this kind of trigonal planar geometry, but what is the problem? Here there is electron. So you can hide this position. Like you can think about there is nothing here, but the effect is there. So how it's look like, just like this. So electron geometry I can draw like this. Okay, so here lone pair of electron is there, and this one is our trigonal planar. Okay, geometry. But here what is the thing? This thing you can hide. Okay, since the effect is there, the electron will not shape like this way is not possible. That's I'm trying to explain. Okay, this bond have to be not like this. Correct? So this particular shape is what we called bent because it's bent, right? It's not like a linear shape. Due to this repulsion, it can't be occupied like a 180-degree. It's not possible. Then what is the bond angle? It's originated from the trigonal planar geometry. So the bond angle is actually similar to 120, or more specifically, you can tell like each lone pair you can reduce 2 point. Okay, which means exactly speaking, it's 180. Like that you can tell. Okay, it's originated from the trigonal planar geometry. So the bond angle is 120. If you want the exact number, it's actually each lone pair you can reduce 2 point. So 118-degree. Got it? That's the specialty in this kind of lone pair case. Let's see. 3 dimensionally, let's see the thing. Here as well. So see, it's diagonal planar, but electron geometry. So these see the difference. Electron geometry is diagonal planar, but what do you mean by the shape? The question is about shape. Shape is not trigonal planar. Shape, or otherwise called molecular geometry, is bent. So see here 118. Okay, 118 or 119. Here it's given 119. It's okay. One usually 118. 2 electron means 2 point we have to reduce. That's all. Okay. Now let's see the next molecule, NH3. So NH3 is look like, so 3 hydrogens are there and 1 lone pair is there. So it's a kind of AB3E molecule, right? So altogether 3 bond pair and 1 lone pair, so 4. So the maximum distance tetrahedral. So electron geometry is tetrahedral. But what about the shape? In order to find the shape, just look the molecule have the same angle, tetrahedral angle, but the thing is, you have to look the molecule without the lone pair. Okay, without the lone pair means the effect is there, so angle will be the same. So this shape is nothing but pyramid, correct? Because we told that tetrahedral is nothing but pyramid plus top of the thing something is there. So here the top thing is not there. Then the remaining stuff is what we called pyramid. Okay. Similarly, water. Water is like oxygen, 2 hydrogen, and 2 lone pairs are there. So it is Ab2E2 molecule. Okay, Ab2E2. So see, all together, again 4 electron clouds are there. So electron geometry is tetrahedral. But what about the shape? The shape is, it's again look like, see how it's look like. It's look like, see, it's tetrahedral oriented, but the problem is 2 are electrons. So just don't want to look at this molecule, but the effect is there. So you can think like this. Okay. The remaining is same. So what does it look like? Is it look like the above shape, any of the above shape? Is it called bent? Yes. Here it's also called bent. So see, SO2 we already studied, that is also bent. Trigonal planar -1. Trigonal planar, like the electron geometry is trigonal planar, but 1 lone pair is what we call the bent. Here tetrahedral -2. Why I am telling tetrahedral -2? Because altogether 4 electron cloud, but 2 are lone pair. Okay, that is also bent. How do you distinguish? See, the angle is different. Tetrahedral bond angle is 109.5. Okay, so here it's around 109.5, or we can reduce some 4 point because 2 lone pairs are there. So like 4 point you can reduce, like 105.5, like that you can take. Okay, that's it. In the top, NH3 also tetrahedral means 109.5. So pyramid angle means 107, like that. Also you can think 9.5. Okay, that's it. H2. So let's see the three-dimensional version. See, this is NH3. See, the top is lone pair. Okay, so this is what you called. So see, just hide this position. Look at the remaining molecule. What's the shape? Trigonal pyramidal. Okay, and then what about H2O? So see, here it's again. You can think about the just look at the molecule through like without the lone pair. So see, the shape is bent. Okay, but still electron geometry is tetrahedral, but that's not the shape, bent. Okay. Okay, now let's see S of 4. So sulfur is actually 6. 4 thing is there. So 1, 2, 3, 4 fluorine is there. So see how many electron clouds? 4 bonding cloud and 1 electron cloud. So altogether 5. So it's an AB4E type. So altogether 5 is there. So it's look like a trigonal bipyramidal. The electron geometry is trigonal bipyramidal. And here how do you tell the shape? So see, this is the trigonal bipyramidal. Shape means you can hide one position because there is 1 lone pair. So always in this kind of shape, given the electron to the corner of triangle planar. Okay. So now you look at the molecule. So see, so just look at the molecule like this. What is the shape? So don't want to think about this position, hide this position, look through this molecule. Is it look like a seesaw? Right. This is what you call the seesaw. seesaw shape. Okay. Then let's see ClF3, or otherwise called AB 3E2. So altogether 5 electron cloud is there, like 5 electron clouds are there. So trigonal bipyramidal. But what about the shape? So see, in this case there are 2 electrons, so we can put 2 electron here, so that look at the molecule so that it's easy to understand what is the shape. So see, is it look like a T shape? See, the angle is 80, sorry, 90, right? So this shape is called T shape. Okay, then what about XCF2? Or otherwise, you can think about AB to E3 type. AB to E3 type means again altogether 5 electron clouds are there. So think about a triangular planar is there and all the 3 position is occupied by electron, lone pair. Then what about this molecule? So see what is the remaining shape. So see, just a linear, correct? So this shape is what you call the linear. Okay, in the three-dimensional diagram, maybe you didn't get that much of idea, like the clouds are there. So just think about this hiding position. In this hiding position, the lone pair hide, then you get the shape. Okay, right. And what about BR5? Or it will be a AB 5 and E. So see, AB 5 and E, which means all together 6 electron clouds are there. So it is an octahedral in electron geometry. Okay, so A is at the center and see 4 a thing in like a square planar, and one is above the plane and one is below the plane. But here electron is there. So one of the position is electron. Now you look at the molecule. Now you look at the molecule. So this is a square planar, and one is there. Okay, square planar is there, and one is like what perpendicular to that plane. Okay, so that is what you call the square pyramidal. Okay, square bipyramidal is actually this octahedral. Square bipyramidal is what we called octahedral, but now one position is not there, so that is what we called pyramidal. Okay, here the corner position you need to write like that condition is not there, because here corner position and the axial positions are same, so there is no difference. Like corner axial, like that, no difference is there, everything is same. Okay, so where you can put anywhere the dots, but for easy understanding I am just writing the electron dots here. In the trigonal planar geometry or trigonal bipyramidal geometry, you can put the corner the electron clouds in the corners of triangle. Okay, okay, last one. What about this one? AB4E2. Okay, AB4E2 means again 5 electron clouds are there. So see the thing, when you draw this one, 2 electrons you can write. So the remaining shape is what? This is nothing but square planar. So that's why this shape is called square planar. Okay, so these are some examples, not one to worry. When you draw the Lewis diagram, you can get this kind of categories. Okay, anyway, let's see that three-dimensional diagram also. So ClF3, so see, it's T shape. This is what we called a T shape. So see, does it look like a T shape? Okay. Then before this one, XCF2. So see, this is what we call trigonal. Bipyramidal is like electron geometry, but see the linear shape? It's linear. Okay. Right. So BRFI, this is the square pyramidal shape. So square plane is there and the one is at the top. So see the square planar shape, and one is at the bottom or top, no issue, like this square pyramidal. Okay, and then see the square planar shape. So the top and bottom should be the lone pairs. So then the remaining shape is called square planar. Okay, so those are the shape. In this way you can tell the shape. So now I'm just concluding all the stuff. So it's very easy. First step, draw the Lewis diagram. Okay. First step, draw the Lewis diagram and then categorize. Like, for example, if it is an AB2 type. So what do you mean by AB2 type? A is the central atom and two bond pairs are there. Then the shape is called linear and the bond angle is 180. Okay, right. Then if it is AB3, then 3 means trigonal planar and the bond angle is 120. And then what about 4? Yes, for maximum distance, you have to say it is tetrahedral and the bond angle is 109.5. Okay, and then see AB5 means 5 maximum distance, it's trigonal bipyramidal and the bond angles are 90 and 120 are available. And then the last one AB6, AB6 is octahedral and the bond angle is 90. Okay, so these are the basic shape. Now, if lone pairs are there, linear there is no other possibility. But AB3 can be like AB2E. So AB2E means what I mean AB2 electron geometry. Total electron cloud is 3. So its trigonal planar is the electron geometry. But what is the shape? Trigonal planar minus 1 is what is bent. Same bond angle since it's originated from 120, so it's nearly 120 or exactly 180. Okay, then here AB4 is available in two combo, like altogether 4 electron cloud means AB3 is there or AB2E2 is also there. Okay, so three bond pair and one electron cloud, like one lone pair. At that time the shape is called it's pyramid. And here it is again called a bent. Okay, but the bond angles are different. This is originated from trigonal by tetrahedral, so 109 exactly, not similar to 109.5. Here it is similar to 120. Okay, right. Then AB5 means AB5 three combos are available, like AB4 is there, AB AB3E2 is there and AB2E3 is there. Okay, so if one lone pair, the shape is called a seesaw. So this one is called a seesaw and this is what we called T shape, and trigonal bipyramidal minus 3 is what we called a linear again. Okay, so seesaw means trigonal bipyramidal minus 1, then T means trigonal bipyramidal minus 2 and minus 3 means linear. Okay, then octahedral is also available in two combo, which means AB4E, which means octahedral, sorry, 5E. Octahedral minus 1 altogether. So electron shape is, geometry is octahedral, but molecular shape is, yes, square pyramidal. Okay, and the last one AB4E2 is square planar. Octahedral minus 2 is square planar. So these are the shapes of molecule. Okay, and that's it for today's episode. I hope you found it helpful and easy to follow. Got any questions or topic you would like me to cover next? Drop them in comment below. Don't forget to like, share, subscribe for more simple chemistry lesson. See you next one. Until then, keep learning and stay curious.